So good day to all. We are here now for the third week of online class for Aptitude. So let us just take a look at what we did in the last week. Last week actually we have talked about 4 different techniques in which you can tackle or solve any aptitude question. So what were the techniques? The first one was just the traditional method by which we can solve any problem given. The second one was a shortcut method using not the direct formula but some basic concepts. The third one was the substitution method, where you just substitute the given options and try to see that which one clicks as the best option, as the best fit. And the last one was elimination method, where instead of finding out the correct solution, we try to eliminate the wrong option so that the one which is left is the correct one. Okay, so now for today's class, we will look into some more ways in which you can tackle aptitude questions in a faster way. And for that, the topic what I have chosen is time and work. This is basically on request of some of you. Some of you had requested me to look into this topic when we had the discussion session in the last week. So I have taken this for this week. Actually, this topic was covered, I think, in your first semester syllabus. This semester we didn't have this time and work. Maybe few problems we have come across when we were doing the direct and indirect proportion, because somehow proportion is obviously coming into picture. So anyway, let us look into in more details in length and breadth in this topic of time and work, and at the same time I will try to give you techniques or formulae or tricks in which you can solve these problems in a quicker fashion. Okay, so first of all, in the time and work topic, I would just like to tell you about some basic concept. And while we come into the basic concepts, the first thing what we should look into is the different parameters or the variables involved. So when we are talking about time and work, of course, the first thing which comes into your mind is work, and let us denote work with W. Okay, next, of course, the work is done by some people around. So the persons involved, let us denote it with P. And finally, the time required to complete a particular work, so it is T. And now the time may be given in number of days, in number of hours. So days let us denote as D and hours as H. Now some problems, the time, it involves both day and hours. Some problem may involve only days or only hours also. Okay, so these are the basic parameters or the variables that can be involved in a time and work problem. Now many of the problems will involve all these parameters, and again there may be problems where not all but some of them will be used. Okay, now next let us try to see what can be the relationship between these variables. Now when we talk about these relationships, I will actually categorize into different kinds of models depending on how the relation is involved. So the first model, I just look into the relation of work with the other parameters basically. So now the first thing, that work is directly proportional to the number of persons involved when the time is constant. Now I hope we understand that easily, because more the number of persons, more the amount of work will be done. Next, if I keep P constant, W will be proportional to T. So again, of course, if we have more time, more amount of work will be done, so it's directly proportional. Next one, number 3, W is okay. Now number 3 and 4, basically I have taken it that the sub cases, that if T is the time is the number of days, then W is proportional to D, and if T is the number of hours, then W is proportional to H. So these are the cases. And now if all these are varying, then of course W will be proportional to PDH. So work will be proportional to the product of the number of persons involved, number of days, and the number of hours. And one thing, if in a problem we have only days and not hours mentioned, so of course that H goes away, or vice versa. And now then, while solving problems, since W is proportional to PDH, this kind of formula will be useful, that if we have in first situation W1 amount of work done by P1 number of persons in D1 days and H1 hours, and W2 amount of work is done by P2 persons in D2 days in H2 number of hours, then we have a relation like W1 by W2 equal to P1 D1 H1 by P2 D2 H2. If you remember this basic formula, we can do a number of problems in a very quicker fashion. So let us come to examples now, which will fit into this kind of model. So question number 1 here, 20 tailors stitch 20 shirts in 4 days, taking 6 hours each day. 10 tailors will stitch how many shirts in 9 days, working 4 hours each day? So of course, this stitching shirts, 20 shirts is stitched by 20 tailors. So that is the work done, amount of work done is that 20 shirts has been stitched. And now number of persons is here tailors 20 in the first situation, number of days is 4 and hours is 6. So if we make use of the formula here, W1 by W2 equal to P1 D1 H1 by P2 D2 H2, let us see what happens. See, in the first case the work done is 20 shirts, so it's 20. P1 number of person is 20, again 4 is the number of days, 6 is the number of hours. And what is happening in the next situation? Next situation, now 10 tailors are working 9 days and 4 hours, and so what we have to find out that how many shirts were stitched, so that is the work W. So now this everyone can solve it very easily by cross multiplication. So I'm skipping the calculations. If you see here, basically 20 10, so you get a 20 over here. Anyway, I'm skipping that. You just come across 20 into 3 by 4 and it's coming as 15. So that means 10 tailors will be stitching 15 shirts. Okay, so this is just, you can get this answer in 20-30 seconds maximum if you remember this formula. Okay, another question of this type, this model, which fits into this model rather. See, so 8 women can complete a piece of work in 9 days, working 15 hours daily. In how many days will 12 women complete the same piece of work if they work 4 hours daily? Now see one difference of this problem with the previous problem. The previous problem, the amount of work was varying, the number of shirts stitched. Now here the amount of work, the piece of work is fixed. So what is happening here is W1 equal to W2. Now if W1 equal to W2, let us come back to the formula. Then this formula leads us to that P1 D1 H1 will be equal to P2 D2 H2. So that's what we will be using here now. So P2 D2 H2 equal to P1 D1 H1. And now see what's happening here. The second situation which we have to find out, the question is in how many days. So the D2 is unknown and 12 women, 12 person are working and 4 hours daily. And now in the first situation what is given, 8 women are working 9 days 15 hours daily. So I hope the equation is very clear, and from here you can solve D2. So 8 into 9 into 15 by 12 into 4. So if you do the cancellation, it comes as 45 by 2. So now 45 by 2, that means 22 and half days will be needed in this second situation. Okay, so now next case I will come to another type of model, and we remember that let us understand that if the work is constant, the number of persons needed will be inversely proportional to the time. Or if we just talk about days, then P is inversely proportional to D. I think we can understand this easily, because if time increases, then of course you will need less number of persons, or vice versa, right? So now we have a difference. We have kept the first model, we were looking into the proportion, how work is proportional to the other parameters, and this model, there are many problems fitting into this kind of model. The amount of work is constant, and now we see that P is the number of persons needed is inversely proportional to the time. Now this kind of problems are usually done by unitary method, which we know, we will explain. And another thing what we will need in this case, that the work done in one day, work done by a person in one day, which is usually called the efficiency or the capacity of a person. So now there are variety of problems involved which we can do by basically this model. So we will just find out a formula first. Say suppose I have a situation like this, that A can complete a piece of work in small a number of days, and the person B can complete the same work in B number of days. Now it's a very common type of question in many problems, that you have a data like this and you will be asked that in how many days can A plus B complete the same work. So A can complete in small a days and B can complete in B days. How many days will be needed by A plus B? But I think we can understand that it's not that because here we are adding capital A and capital B, that does not mean that the right hand side small a and small b also gets added. It cannot be, right? If A plus B, two persons are working, basically the number of days should reduce. It cannot be A plus B. So this kind of problems are done with finding the work done by a person in one day, or rather the efficiency of a person, and then we solve it very easily. So you see, now A can complete a work in small a days, so work done by A in one day is obviously 1 by A, because we take the piece of work as a whole 1. So work done by A in one day is 1 by A. Similarly, work done by B in one day will be 1 by B. And now we can add up basically work done by A and B. The total work done by A and B in one day is 1 by A plus 1 by B, which comes up to be A plus B by AB. So now in one day the amount of work done by A plus B is A plus B by AB. So in how many days the total work will be done? The total work is 1, so obviously we just reciprocate. So therefore the number of days required now by A plus B to complete the work is AB by A plus B. So just remember here, as I told that we have to just reciprocate. So please remember here that number of days is equal to 1 by capacity. So if we remember this basic thing, we can do the problems in a very quicker manner. And if we remember the formula also, we can just put directly the formula, or we can follow the steps when we will get a particular problem, whichever you feel convenient. And now here I had taken this, I have brought this formula when we have two people, A and B. Now this formula can be extended basically to more number of persons. So suppose we have A, B and C. So work done by A in one day is 1 by A, for B it's 1 by B, and now for C it is 1 by C. So the total work done by all the three working together in one day is obviously now 1 by A plus 1 by B plus 1 by C, which if you calculate it comes to be AB plus BC plus CA plus the CA and divided by ABC. So therefore now the number of days required by A plus B to complete the work, as we already told that we have to just reciprocate, so therefore it's ABC by AB plus BC plus CA. Now I am not going into further extension of the formulae, but we should understand that this formula can be extended for any number of persons, even for 4, 5 or more. Okay, so now let us come to a problem quickly. Ravi can do a piece of work in 30 days while Prakash can do it in 40 days. So now your two persons A and B, that's Ravi and Prakash, and the number of days small a and small b are 30 and 40. So if we have to find the number of days required by them to finish the work together, if we can do it in both ways. Basically we can follow the steps as we have done for deriving the formula, or you can directly use the formula, whichever you feel convenient. But sometimes following the steps is easier. Okay, anyway, first let us see direct formula. So by direct formula the number of days is AB by A plus B. So A and B were 30 and 40, so it's 30 multiplied with 40 divided by 30 plus 40, 120 by 7. That is your answer. And let us just look a quick glance that if I would have without using the formula just followed the steps, then we know that Ravi can do a piece of work in 30 days. So therefore the amount of work done by Ravi in one day is 1 by 30 and Prakash is 1 by 40. So both of them together it's 1 by 30 plus 1 by 40, 7 by 20. So number of days is again you reciprocate, 120 by 7. I should say in many cases doing in the, instead of using the direct formula, doing like this might be convenient for you, particularly if you have 3 variables. Okay, so I hope it's clear. And now let us take up another problem with the same basic concept. So it's a little bit more complicated than the previous one, but we can go by the same formula. So A and B together can complete a work in 12 days. B and C together can finish the same work in 6 days. If A and C work together, the time taken by them is 16 days. So the question is now, in how many days can A, B and C together finish the work? So as we have used already the formula, I'm just writing it quickly. So A plus B, the time needed by them is 12 days. So therefore in one day A plus B can do, the amount of work is 1 by 12. Similarly B plus C is 1 by 6, and A plus C, they take 16 days. So the amount of work done in one day is 1 by 16. So therefore if we now add up, you see in these 3 equations, if we add up, A appears twice, B twice and C twice. So what we get is 2A plus 2B plus 2C, that is 1 by 12 plus 1 by 6 and 1 by 16. So if you just add up, do a little bit of calculations, it comes as 15 by 48 or 5 by 16. And therefore A plus B plus C comes as 5 by 32. So that means in one day A plus B plus C can do 5 by 32 part of the work. So the whole work will be finished in, again the reciprocal, so 32 by 5 days. Okay, so the same thing, the same formula. So we have now seen by now 2 different models, and now another case I will come up with a third model where another category of problems where maybe some men are working, children are working, women are working, so different types of people are working. So sometimes we need to do a measurement of the work, that how much amount of work has been completed. So in this kind of model, so we measure the work as men multiply the amount of work done by the number of person basically with the number of days, or if it's in hours, men into hours. So we call it as man days or man hours, like this. And this kind of problem, the clue is that we balance the total work in both sides by calculating the man days or man hours and then try to solve this problem. So let us see which kind of questions can be fitted into this model. So now we have a question here around a work is started by 15 people. After 5 days, 5 more people joined and the work is completed in next 10 days. How many people should start working from the first day if the work needs to be completed in 11 days? So this is a question which can be done by measuring the amount of work in the first situation and in the second situation. Now see, in the first situation what it is telling, that work is started by 15 people. After 5 days 5 more people have joined. So up to 5 days 15 people has worked. So the amount of man days is 15 into 5. So we have here 15 into 5. The equation is it's already visible now. So let us just see what's the meaning of the equation. So for first 15 days the man hour days used is 15 into 5, and what is happening after 5 days, 5 more people have joined. So total number of people is 20, and how many more days they are working? They are working for 10 days, so it's 20 into 10. So in the first situation, when the work was completed in these two parts, this is the total man days which has been involved. So the total amount of work we can measure like this, and we equate this on the right side with the situation that when we are asked to find that how many people should work from the first day, let us call it M, so that the work is completed in 11 days. So now the amount of people involved is M and time or the days is 11. So we have an equation like this, balancing the total work done in both sides, and this it's very easy to solve. So M, it comes as here it's 75 plus 200, so 275 by 11, so 25. So that means if we want to complete the work in 11 days in a uniform manner, then from the first day 25 people should start working. Okay, so this is a type of question which can be done by balancing the total work by measuring the man hours or the man days. One more question of this type which fits into this model, rather not exactly of this type. Okay, so now we have a question: 20 men working 8 hours a day take 20 days to build a bridge. After 12 days, if 12 people quit, then how many more days will it take to build the bridge? So here also we will frame a very similar equation by balancing the work done in both cases and then try to get our answer. So if we look into the first situation, you see 20 men working 8 hours a day take 20 days to build a bridge. So therefore the men hours used in this case is so what is that? 20 men are working and 8 hours and for 20 days. So the total man hour needed is 20 into 8 into 20, right? So this is our left hand side. And what is happening the right hand side, that this would have been the ideal situation, but what has happened that after 12 days 12 people quit. So that means up to 12 days 20 men were working. So it is again 20 men were working for 12 days and 8 hours. So 20 into 8 into 12. And what is happening for the rest of the time? So rest of the time 12 people quit out of 20. So now 8 people are working 8 hours a day, and we don't know how many days they should work. That is our unknown. So let us call it as D. So if we can frame an equation like this, just balancing the work done, measuring the work done on both sides, we can easily get our answer. So now we can easily solve. So your D is this 20 into 8 into 20 minus 20 into 8 into 12 divided by 8 into 8. So this again 20 into 8, 20 minus 12 is 8. So the answer comes to be 20. So that means if 12 people quit, then the remaining people have to work for 20 more days to complete the construction of the bridge. Okay, so with this example we will stop for today. So once again, to summarize, so we have talked about different problems on this time and work, taking into consideration 3 different kinds of models. The first model was where we have looked into how the amount of work varies with the number of persons or the number of days, and we had a very general formula. And the second case was we are using basically the unitary method in the second case, where we are calculating the capacity or the efficiency of a particular person and then getting the answer. And the third case is we are measuring the amount of work by the number of men working as well as the number of days or the hours, or rather the time required. Okay, so we will stop here. So whatever questions you have on this, you can just put up in the discussion session, which is just going to start in a few minutes.